Closed-loop manufacturing with Siemens Accelerator. Connect the physical world and digital world. With the digital twin of the product as well as production, enable intelligent manufacturing. Learn lessons in the digital world from the shop floor to ensure that you make it right first time. Closed-loop manufacturing within a digital thread means complete traceability through a product development process, as well as any change management, all the way through to the shop floor. Stay in control with the ability to identify key quality characteristics and the impact of any issues or changes all the way back to product requirements. In this session, we will look at how closed-loop connections bring feedback from the real world. This will consist of manufacture planning, shop floor execution, and non-conformance management to drive continuous improvement. The manufacturing bill of materials is an effective representation of the design structure grouped by the manufacturing assembly, whereas the engineering bill of materials, or EBOM, represents the product architecture. The manufacturing bill of materials, or MBOM, is the build according to the manufacturing assembly order. Let's look at an example of how we initiate our manufacturing plan with a work package and then align the EBOM to MBOM for an aerospace component called the winglet. First, I will create a work package to group my manufacturing plan. Now I will associate my design structure and create a top-level MBOM assembly. Additionally, a bill of process which details all the manufacturing and assembly operations is associated. Now, to align the EBOM to MBOM, I cluster elements from the EBOM to the manufacturing order within my MBOM with an alignment check, and additionally assign components that I may need, such as glue or rivets that are not typically in an EBOM. That is how key components from design are best positioned for use with assembly or manufacturing, making it easier to manage changes concurrently and work with up-to-date information. Once the manufacturing bill of material is created, the bill of process, which provides the process steps, can further be enriched with work instructions, part association from the MBOM, and further detail to the sequence of operations. Firstly, I'd like to create a winglet assembly process of which to associate a group of material components that will be assembled together. Within process planning, I can further define operations and associate documents such as operating procedures. This will further be collated with quality inspection points such as a visual check from a control plan and then sent to the shop floor execution system, Opcenter, to continue a holistic approach to managing product development. Quality is crucial to upkeep standards and meet the design intent of the product. With control and inspection plans within Teamcenter, we will look at how key product characteristics are identified and leveraged from a 2D engineering drawing or a 3D model to associate to the shop floor operation. Firstly, as a quality engineer, I wish to create an inspection plan process. This will consist of operations for product checks. The checks will be identified within the control plan that we see here. The characteristics within the control plan have been identified from the associated part manufacturing information. If I select this out case, I have a 2D engineering drawing with the associated characteristic information. Since I'm interested in the winglet, I'll select that part and notice the two characteristics highlighted in green have already been imported. I can view the characteristic and feature within the model here too. All the dimensional information is imported and I can further associate reaction plans and potential defects to aid the operator or inspector if a non-conformance arises. A visual check also advises the operator which area to select for any potential issues. Once I am content with the control plan, I can associate this with the quality inspection process ready to be sent to the manufacturing execution system. The use of up-to-date design data directly connected to the shop floor ensures you can effectively manage quality and streamline the manufacturing or assembly process.
Now that the bill of process and inspection plans have been defined in Teamcenter, Opcenter provides our operators with the instructions, documentation, and quality controls to complete their task whilst validating material and tooling usage and collecting process data. Let's see how. The operator landing page is ergonomically designed for touchscreen so I can touch select and start my operation. Documentation and work instructions, authored and controlled in Teamcenter, are presented to me and requires my acknowledgement before I can proceed. Material validation is done at the point of consumption with the ability to Opcenter to allocate line-side materials, and I can scan and validate serialized components. With connectivity to smart tooling, Opcenter can acquire data from my shop floor operations and automate the data collection, such as torque measurements. Tooling data such as usage count and time is obtained and recorded from the connection to give me a better understanding of my equipment's health. Quality inspections defined in Teamcenter are monitored and controlled with Opcenter. It presents me with interactive visuals, key feature aspects and measurement tolerances with the ability to control the sign-off with my supervisor using their credentials. And with all the data collection done as part of executing the operations, Opcenter provides a comprehensive end-to-end traceability of the material, with each interaction of the process as a digital record to provide a detailed as-built digital twin.
To have effective non-conformance management, a company needs clear communication and collaboration between shop floor and engineering. Let's see how an operator can raise a non-conformance, attach the relevant details, and notify engineering. During an inspection activity, I found some damage on the wing, so I'm going to raise a non-conformance in Opcenter and assign the scratch failure category. I'm going to link the component serial number and attach the required information and images to allow an engineer to make an informed decision. Stepping into the shoes of an engineer, I've been notified of the defect and I'm now able to review the details, history and attached images from the shop floor of the non-conformance before transferring it to Teamcenter for investigation.
With closed-loop manufacturing, concerns are fed back from the shop floor in real time back to Teamcenter. We will go through a specific concern associated to a winglet and through a prescriptive process establish the root cause. Firstly, I wish to locate the scratch that has been identified for the winglet, which occurred during the manufacturing process. Straight away, I am presented with the key information that I need, such as the type of concern, the owner, and relevant imagery. I am also informed at which stage of the program the part resides in, and any related issues. Now to go through the problem-solving process. To establish the root cause of the scratch, I need to look at the overview and a summary of all the information that's been collated during the investigation. This consists of identifying the defect from a catalogue, evaluating the risk, and determining all the actions that have been carried out throughout the process, such as the containment and preventative measures. The Root Cause Analysis tab encourages you to apply an effective root cause analysis technique, such as the 5-why analysis, or additionally, the Ishikawa or fishbone diagram to assess all possible factors that could influence the cause of the problem. Once the root cause was determined, corrective and preventative actions can be placed to ensure lessons are learned for future programs. Actionable insights can be drawn upon for a more broader view of what is required to trace organizational performance and drive continuous improvement. And that is how non-conformities from the shop floor are managed effectively to stay in control of your workload and optimize your product quality.
Now engineering have investigated the defect and defined a rework process in Teamcenter. This will now be made available in Opcenter to assign to the non-conformance and send back to the shop floor to be repaired. I can see that the non-conformance status has been changed back to open and a rework process is now available to select and issue to the shop floor. As a shop floor operator, I have a new rework order which I will now execute as part of the non-conformance to correct the defect and collect operation data before it is returned and continued on its original work order. With closed-loop manufacturing, your processes are optimized based upon the feedback of an issue from the shop floor to your engineering to redevelop a best practice approach to managing the manufacturing operations.